Hello. The next series of videos you will watch, I will be posting on Thursdays. I'm going to be calling it Throwback Thursday. And these are videos that I had originally posted for instructional purposes on my old YouTube channel. They did decently well, especially for somebody who wasn't maintaining a YouTube channel at the time. I hope you enjoy. Hello class, in this video we're going to talk about constructions of certain triangles. Now the most popular and most famous construction of all time is probably the construction of equilateral triangles. But I figured just for fun, why don't we go through some other kinds of triangles and all the ones specifically that we've discussed in class. So as mentioned before, the equilateral triangle is the most famous, so we'll start with that. Now, in the last video, I ended by saying if you're never given a line or a segment, or even points for that matter, you can put your own on the page wherever you want. And I mean, how do we construct a triangle out of thin air? We got to be able to start with a given length. And I'm just going to go ahead and I'm going to put it as far down to my space as possible to leave myself as much space up here. I'm just going to go ahead and do that. I'm going to call this A and B. And it's going to seem a lot like our perpendicular bisector instructions because we want to set the compass to a certain length, but this time it has to specifically be length AB. So we need that length. And we don't need an arc below the line segment this time, we just need it above. So if I go ahead and draw it there, and then center it at B, draw it there, we have our third point of the triangle, C, and we can go ahead and connect points. The reason why this is so famous is because if I were to have drawn pardon me, paper's getting away from me. If I were to have drawn the entire circle, you could see that each one of these lines is a radius of the circle of the same length. Let's talk about isosceles triangle. The isosceles triangle reminds me a lot of perpendicular bisector, and the reason is, again, I can set my own length. I'll go up the alphabet. I'm going to call this D and E. I guess I'm going down the alphabet, but that's neither here nor there. I want to set, again, my compass centered at D and to a certain length, but I don't want to go to the entire length. I want to go more than half. So once again, I could extend beyond the line, or I could go less than the line segment itself, but it's still got to be more than half. And this time, it can't be equal to, because as we've seen, when it's equal to, it's an equilateral triangle. So I'm going to go right about there. I always like to go less, because I know I have enough space for it. And once again, I'm going to draw an arc above the circle, but not below. And then I'm going to turn it around on E and do the same thing. Draw my final point, and you can see an isosceles triangle start to take shape. Now, usually, actually, what I like to encourage you to do is on an equilateral triangle, mark them congruent. Mark these congruent as well, so we know which sides are the true congruents. Scalene triangles might be the easiest one we tackle because it doesn't even require the compass. Scalene triangle being a triangle with 3 non-equal sides. Let's just go ahead and draw a random length triangle. And we'll call it a scalene triangle. Now the question is, how do we know that's scalene? I just drew 3 segments on the page, and how do I know that they're all not equal? Well, again, we can't use measurements, but we can actually use our compass to double check. So if I go ahead and put this up here, I can see this isn't equal to either of these two sides. That's obvious. But if I set this to this length and then I try to move over to see if it's equal to the length, you can see it actually extends beyond. So this is a scalene triangle. I'm going to go ahead and label my points. So I would have ended on G. I don't think I labeled it G, but I would have ended on G. So this is H, I, and J. So number 4 says we're going to construct a right triangle. And I actually like this construction because it preps us for when we're going to construct a square and when we're going to construct rectangles. So I'm going to start with a segment. I'm going to make it extra long. It's not going to end up being this long, but just to give myself extra space. Because what I want to do is I'm going to plot a point on the line here. And what I'm essentially going to do is I'm going to create a line through this point that is perpendicular to this line. This is a construction we've already done. And if you've practiced this, then you have this down. This should be no problem. So we'll call this K. I'm going to go ahead and set it to a length, and I'm going to make sure it intersects on both sides. So this is one thing you'll find with me when we do constructions like this. I only like to take the arcs I need. That comes with experience though, so if you're not there yet and you're drawing the full circles, again, it doesn't make a difference. That's personal preference. So K, L, M. And now we just create a perpendicular bisector of this segment. So set it at L and set it to more than half the length. I'm just going to draw my arc above. I'm just going to draw my arc above because we only need 2 points to create a line, and we've already got K. So now we have N. And I'm actually not going to draw it as a line. I'm just going to draw it as a segment. And there's my right angle of the right triangle. Now the last part is merely to draw another point, O, somewhere on the line. So these last two constructions are rather nice because we don't require the compass. We know what a right angle looks like. So when we're talking about constructing an obtuse or an acute triangle, we just have to draw angles that look obtuse and acute without really knowing their angles. So if I just go ahead and start with an obtuse angle, that happens when you don't hold your ruler down all the way, and it happens to me quite a bit. And then I extend it, I'll say that far. You can see that is obviously greater than 90 if we just look at it. Now if we wanted to check our work, we could always construct perpendicular lines and compare the two. But it's kind of like a scalene triangle. We don't need to actually use the compass for this one. We have visual perspective. We know what obtuse angles look like. And if you wanted to make it more obvious than that, and then acute triangle is the same. Now, as discussed previously in videos, the equilateral triangle is a famous acute triangle because all angles are 60 degrees. But I'm not going to strive for an equilateral triangle. I'm just going to go ahead, and this one's a little bit trickier because you got to get the angle measurements just right to make sure you can't just start off with an acute angle. I'm going to go ahead and do it right here. And that's a little extra. Yeah, we got less than 90, less than 90, less than 90. And we'll call this S, T, and U. Thank you for watching.